All right, so 10.2 is putting together the skills that we learned in 10.1 and adding just a little bit more calculation. So we're actually going to find the confidence intervals, and we'll see that our last step is very similar to a problem we did in 10.2, and our first step is in 10.1, and our first step is very similar to the critical values we found in 10.1. So the very first thing we're going to do in this problem is find the critical value for a 99% confidence interval. But let's read the whole thing first. You measure 41 textbooks' weights and find they have a mean weight of 64 ounces. Assume the population standard deviation is 2.4 ounces. Based on this, we want to construct a 99% confidence interval for the true population mean textbook weight. So here's our formula for a confidence interval for the mean. We're going to take our sample mean x bar, and well, we've got that plus minus again that we saw in the last section. Z is our critical value, our critical number, and then our standard deviation for the population over the square root of our sample size. All right, so let's fill in first by finding out what Z is. So to get our Z, remember what we did is we subtract off our confidence level as a decimal from 1. So our confidence level was 99% back here, 99% confidence interval. All right, so we're going to subtract that from 1. And then, of course, after we do that, we'll divide by 2. And if we divide that by 2, we get 0.005. And I believe we did that problem in a previous video, but we'll go ahead, and it's probably this answer right here. But just to recall, I and V 0.005, and it is that. So we get 2.575, and again, I'll just copy and paste it. Now, it doesn't matter that it's negative because I'll go ahead and say Z is this value. All right, and I'm going to take the negative off, and the reason is that minus sign that we have in our formula takes care of the negative part of the critical number. So we don't really have to have it as we plug in. All right, so let's go back and find our mean and our standard deviation. Let's see, our mean weight is 64. Population standard deviation is 2.4, and there are 41 textbooks in the sample. All right, so 64 is our x bar, plus minus. Z is 2.57583. Keep as many decimals as you can as you do these calculations. Sigma was it 2.4? Yeah, 2.4. Sigma is 2.4 divided by the square root of, what was it, 141? 41, just 41. 41. All right, now let's take this a step at a time so we don't make mistakes in the calculations. So the first thing I'm going to do is I'm going to do the square root of 41. And the square root of 41 is going to be 6.403124. And notice I've taken out about 6 decimal places. The more decimal places, the better. So depending upon what your calculator gives you, you want to take this out as many decimal places as you can before you do it. All right, so now I can actually do everything that's to the right of my plus minus in my calculator. So I'm going to go ahead and do that. So I'm going to do the 2.57583 times 2.4 divided by 6.403124. And that gives me 0.965465. All right, and then finally, 2 calculations. 64 minus, oops, and that should be 0.9. There we go. Minus 0.965465 and 64 plus 0.965465. Let me move that up a little bit so we can see it better. All right, so first calculation, I will do the 64 minus that number, and that gives me 63.034535. And then, of course, this one I can do very quickly, 64.965465. And those are our two ends of our confidence interval. Now, depending upon what the question is asking, we can put them in interval notation. And I'm not sure, no, we just need to put them in the blanks here, but let's see, we want to round to 2 places, so let's round to 2 places back here. So in the first blank, we're going to put 63.03, and in the second blank, we're going to put 64.97. And there's our confidence interval.